Physical change. We're going to talk about physical and chemical changes, physical and chemical properties. A physical change alters only the state, solid, liquid, gas, or the appearance. It doesn't alter the composition. So the atoms or molecules that are composing that substance are still the same. So if you take a piece of wood and you cut it in half, that's a physical change. You've changed the size of the log, but it's still wood, right? You take a piece of metal and you smash it flat with a hammer. The metal is still the same. It hasn't changed. It's a physical change. Water boiling. So here's the water, and you boil it, and it goes into the gas state. The particles, if we could look at them, we would see that the particles are the same. Don't those look like little Mickey Mouse heads? Somebody. Yeah, they do. Little Mickey Mouse heads. So here's water. And in the liquid state, it's all close together. When it boils and goes into the gas state, the only thing that changes is that it moves apart. The individual particles are the same, and that's a physical change. The particles remain the same. In a chemical change, the particles do change. They come apart and rearrange. So the original substance is destroyed and transformed into a new substance. So an iron nail rusting. So in iron, the iron atoms are arranged in a very specific pattern. This is an example of a crystalline solid. And when it rusts, it combines with oxygen, and it becomes a different substance. And it has different properties, right? Rust is not something you would want to make a car out of. It just doesn't have much strength, whereas iron is strong and hard. So that's an example of a chemical change. The individual particles have rearranged and recombined and are different, and that's what makes a chemical change. So here's some examples from your textbook of physical and chemical changes. So here's a piece of dry ice, kind of looks like an iceberg. Dry ice is solid carbon dioxide. And solid carbon dioxide doesn't actually melt. It goes straight to the gas state, and that's called subliming. So it goes to the gas state. The particles are the same. So is this chemical change or physical change? It's a physical change. You should be able to get that because it says physical change right there, but it's an example of a physical change. Anytime you change the state, you melt it, you evaporate it, you freeze it, any of those state changes are physical changes. Sugar dissolving. You put some sugar into water and you mix it up, it seems to disappear, right? What's going on? Well, here's an illustration of crystalline sugar, these big funky looking molecules, and they're all lined up and everything. When you put them into water and stir it up, those individual sugar particles remain the same. They are just mixed with the water. So the particles haven't changed. The process of dissolving one thing in another and mixing it together is a physical change. They've become mixed up, there's a change, but the individual particles are the same. Here we have propane gas burning. So here's the propane gas, and when it burns, it combines with oxygen in the air to produce carbon dioxide and water. These particles have been destroyed and new particles have been formed. I wonder if they're missing their chairs next door. We'll have to give them back. So that's changes. And then there's properties. Physical property is a property that a substance displays without changing its composition. When you smell gasoline, it has a distinctive odor. The act of smelling the gasoline does not change the composition of the gasoline. Odor, taste, color, appearance, melting point, boiling point, density, these are all examples of physical properties. You can measure these things, you can observe them, and it doesn't change what the substance is. A chemical property can only be observed by a chemical change in which the substance changes. It's also known as a chemical reaction. So gas is flammable. When we observe that property, that chemical property of gasoline, that it burns, it becomes a different substance. It undergoes a chemical change. Iron rusts. That's a chemical property. When iron rusts, it becomes a different substance. Corrosiveness, acidity, toxicity, these are examples of chemical properties. So here's an example. Determine whether each change is physical or chemical, and what kind of property is demonstrated in each case. So let's look at A. A copper wire is hammered flat. Is that a chemical or physical change? It's a physical change. What kind of a property is being demonstrated? A physical property. A physical change demonstrates a physical property. A nickel, the coin, dissolves in acid to form a blue-green solution. Chemical change or physical change? Chemical change. The nickel atoms in the coin have recombined with the acid and are forming a blue-green solution. So is this a chemical property or a physical property? Chemical property. Dry ice sublimes without melting. Chemical change, physical change? Physical change. And that is a demonstration of a physical property. A match ignites when struck on a flint. Chemical change. And the chemical change is demonstrating a chemical property.